Hello, and welcome to this presentation on Brushless DC motor controls using PIC18Fxx31 microcontroller. I am Padmaraja Edamale with Microchip Technology. I am an application engineer with the Microchip Technology and mostly working on motor control related projects. Today we are going to see a few of the aspects of how to control a brushless DC motor using PIC18Fxx31 microcontroller. So let us move on to the agenda, where we are going to see first an overview of motor control solutions from Microchip. First, we will discuss an overview of motor control solutions available from Microchip, and then we will move on to see few of the peripherals on PIC18Fxx31 microcontrollers which are useful for motor control applications. We will discuss the major peripherals that are helpful in developing motor control applications using PIC18Fxx31. Then we will discuss how to control a brushless DC motor using PIC18Fxx31 devices in open loop, closed loop with Hall sensors, and closed loop with quadrature encoders, or which are also known as optical encoders. Finally, we will see how a sensorless control of brushless DC motor can be implemented using PIC18Fxx31 devices. At the end of this discussion, we will show few references that would be helpful for you to understand brushless DC motors and their controls using PIC18Fxx31 and other devices from Microchip. These include application notes, demonstration boards, and other collateral materials from Microchip. Let us see what are the motor control solutions available from Microchip. Microchip Technology offers a broad product portfolio that provides a complete system solution for your brush DC motors, variable speed brushless DC motors, AC induction motors, switch reluctance motor, and stepper motor applications. This includes the microcontroller with firmware to drive the motor, analog op-amps and comparators for sensors or feedback, and power electronics from Microchip and international rectifiers. With our sophisticated development systems and technical documentation, Microchip makes it easy for designers of all experience levels to complete a high-performance electronic motor control design quickly and cost-effectively. Microchip provides everything a motor design engineer needs: low-risk product development, lower total system cost, faster time to develop and market, outstanding technical support, and dependable delivery and quality, to list a few. For access to Microchip's complete motor control design resources, visit us at www.microchip.com/motor. Here you will find all the application notes, all the devices which are useful for motor control, and other solutions available from Microchip Technology. Let us just look at an overview of PIC18Fxx31 devices. A PIC18Fxx31 family of microcontrollers have 4 members in this, having 28 pin and 40 or 44 pin packages with 8 kilobytes and 16 kilobytes of flash program memory built around 8-bit RISC core, as seen here. An example of 18F4431, which has a flash memory of 16 kilobytes and RAM of 768 bytes. In addition to this, this has many peripherals which are useful for motor control applications. This includes power control PWM, or also called PC PWM here, and high-speed analog to digital converters, which can go up to 200 kilosamples per second. It is a 10-bit analog to digital converter, and motion feedback module, which has 3 input capture inputs and a quadrature encoder interface that we are going to see in detail in coming sections. In addition to this, we have other legacy peripherals that all other PIC microcontrollers carry: 4 timers, timer 0, timer 1, timer 2, and timer 5, EEPROM, 256 bytes of EEPROM, 2 CCP modules, enhanced UART and SSP module, or serial synchronous port module on this. For detailed data sheet of this family of microcontrollers, please visit www.microchip.com. Now let us see the peripherals that are useful for motor control applications. The major peripherals that are useful for motor control applications are power control PWM or PC PWM, as we have seen earlier, high-speed analog to digital converters, and motion feedback modules. These peripherals simplify the motor control algorithm to a great extent. You will see few of the features of these three peripherals in this section. Main features of PC PWM include these: up to 8 channels output with independent or 4 pairs of complementary output. This is useful in motor control applications where a 3-phase or multi-phase motor has to be controlled. This PWM can be put in center-aligned or edge-aligned operation, which is also known as symmetrical PWM or asymmetrical PWM operation. This gives up to 14 bits of resolution. So based on your application, you can set or get the resolution. This has programmable deadband control for complementary outputs, and this has hardware fault interface pins for fast PWM shutdown in the event of fault. In case of any fault in the system, this pin can be used, and this feature can be used to shut down the PWM as soon as possible without intervention of firmware. Next, let us move on to the features of high-speed A to D converter. The high-speed A to D converter has up to 9 channels in 40-pin microcontrollers, and in 28-pin we have 5 channels of A to D analog to digital converter. This can go up to 200 kilosamples per second, and this has 2 samples per hold circuit. There are different modes available in A to D converters. There may be simultaneous conversion or sequential conversion with multiple channel selection or single channel selection. This also has forward deep FIFO with flexible interrupt settings that are suitable for motor control applications. Let us move on to see what are the features available on motion control, motion feedback modules. There are 2 modules multiplexed in this motion feedback module. First is quadrature encoder interface, and second is input capture. Quadrature encoder interface or optical encoder interface has A, B, and index signal interface for measuring position, velocity, and direction of rotation. All these 3 signals can be interfaced to 3 pins available on the microcontroller, and user can get